Okay, and we is on. Whoa, I'm big. So I gotta find out how to edit this thing real quick. My full minute did not give me enough time to hop in here and update my content thingy, which I still don't see it on the YouTube side for whatever reason. Guess it's not a big deal, but I do want whatever. I guess it doesn't matter until it becomes like a normal video. I'm guessing. Whatever. Who cares? Much ado about nothing. So what we're doing today is we have, so GajuDesk is it's a key manager. It's a wallet for the Gajumaru blockchain system. It already manages keys on your local system and interacts with blockchain. Okay, cool. It can send spin transactions. It can build there's a whole bunch of stuff now. You can write contracts, deploy them from there, pull contracts from the chain, call them, all that stuff. You do all the blockchain stuff. Now, a problem that we have regularly inside of QPQ, we've had it at StudioI, we've had it a bunch of places. This comes up over and over, is I want to send a private document to somebody, or I want to record a video and send it to somebody privately, or an internal company briefing, or whatever. And I don't want to blindly trust that Google's not going to mess with my thing, or I want to share it with a specific person, but not everybody else, whatever. Point-to-point secure file sharing. That is a real need, and all kinds of information in the world is confidential. You don't want to just hand it over to everybody. You definitely don't want to hand it over kind of like whatever kind of like legal things that you've got going on, or business things you've got going on, or things in development, or maybe just private family stuff, whatever, that you don't want to give to Apple and Google and Microsoft and all them, because they're already spying on you. The whole reason that, remember, like Gmail would store your mail forever, all of your mail forever. There were no limits on storage. There was no limits on Google Drive, all that stuff at the beginning. Now that they've trained their AI on your stuff, now, oh yeah, well now we've already used that, so we can wipe it all out. So now they've got storage limits. Now they're getting rid of old stuff. Now, if you have an old email account you haven't used in a long time, they'll purge it, right? They're cutting their costs by getting rid of all this old stuff. But they wanted to keep it until they could do this training thing. So now they've gotten what they think is the value out of the big data and blah. So are they continuing to look for high perplexity data that they can train on? Yes. And that high perplexity data is mostly stuff that's private. And they've trained you into using their services for confidential data. Not smart. It's not smart for you to use those things. So given that GajuDesk it's a private key manager, and it's private key. There's a public half and a private half. We're doing public key encryption. We have all the tools necessary already to do a number of things. One, we can encrypt some private data that's intended for somebody with their public key if we know the public key. Now, in the Gajumaru system, public keys are your ID. So your ID and your public key are the same thing. So this is easy. If I want to send a file to my buddy, I ask him for his ID. That ID is a public key I can use to encrypt the data. And the only person in the world that can decrypt it is that guy, because he's got the private key. So that being the case, GajuDesk has like already got all the stuff necessary to build a secure point-to-point data sharing service. Now, there's another component of the problem, which is the reason Google and Microsoft and all these other services will let you send things for free or share files for free or whatever is because it's not really free. It costs them money to let you do that, but they're taking something from you, which is that data itself. You're the product and you're being sold. So how do you prevent there from being a perverse incentive to sell you and make you the product? Well, someone's got to pay somewhere, right? So the most honest version of a secure file sharing service is the person who's sending the file pays some tiny amount to for the benefit of using the service. Now the problem is that network fees are really small. Like the cost of a credit card transaction is like, tens of cents or hundreds of cents. So you're already looking around like dollar values just to run a credit card transaction. But the cost of sending a secure file, even a large file, let's say I want to send a file to my buddy and he's going to have to pick it up from wherever it's stored. So I'm going to upload it to a drive somewhere. That drive's going to hold it until he downloads it and then it'll be deleted, right? So the storage period needs to be paid for and the network transit needs to be paid for. So the bandwidth needs to be paid for and there's going to be temporary storage as well. That needs to be paid for. So how big is the thing? It's going to be as a bandwidth and a storage question. And then how long is it going to be available to the guy? That's a time question. Both aspects of this have some cost for whoever the service provider is. If they're not charging you anything for it, then it's like suspicious. You should wonder, like, how are they doing this for free? So the most honest version of this is you pay a tiny amount to transit that, but the amount is like, around a penny, maybe a couple cents to transfer, store, and then transfer out, transfer to the final destination. A secure file should be like a couple pennies, right? But a credit card transaction is hundreds of pennies. So it doesn't make sense for the payment transaction to cost significantly more than the payment you're trying to make. So also the granularity of this, if I'm trying to send a 1 megabyte file, like a PDF, that's the common case, right? That's going to be like 1/100th of a cent. If I'm trying to send 100 megabytes, that might be a cent, right? So maybe sending a gigabyte's like 10 cents, all told, right? So given that some people might want to send a 1 megabyte file and some people might want to send a gigabyte file, that's 1,000 times different in size. And that's 1,000 times different from the service provider's perspective. All they care about is the bandwidth and the storage, right? Because they can't look into the thing because it's encrypted. It's completely like end-to-end encrypted, so they can't look inside. So that data is useless to them. It's just a blob of stuff. It's just a blob of bytes that they're going to transit. That's all they're doing. So someone's got to pay for that, but the payment might be like a sub-cent amount. You can't do credit card transfers for that. And secure file transfer, it comes up all the time, but it's usually like a one-off deal. Like, oh yeah, send me the contract. I don't want anyone to read it. Just send it to me so I can review it, make changes, maybe send it back. But I want to be completely private. And we're not sure how to really do that well. And we don't want to go over email. We don't even want a record that it went between me and you or whatever. That case is a sub-cent amount, and it happens like once in a blue moon. So it's not something that's worth paying. Like, I'm gonna buy like a point card with $100. So now the credit card transaction makes sense for the $100 thing purchase, and then I'm gonna spend through that. Well, most people are never gonna spend $100 of secure file transfer like in their whole life. So it's a difficult. It's like an unserved business case, and so the businesses that are helping people do that are all like kind of cheating the customer by selling them down the river or scanning the data, or it's not really confidential, or there's always some weird like thing going on that makes us a little dishonest. So all that said, we have a case now where on Gajumaru we can charge teeny tiny sub-cent amounts. The transaction fees on the chain are really small, so it makes sense to pay like that. The payment can be verified by the service provider. And the service provider doesn't have to do all this annoying crap like integrate with the payment processing thing. They don't have to deal with like the all the compliance stuff around credit cards. You just don't have to do any of that stuff. You don't have to have a website even. So you don't even need to have a website. If you can do a way to, if you could pay for this service in Gajus, sub-cent charges are totally fine. You can pay per byte, right? Maybe that's what we'll do today. We'll do per byte service fees. The payment could happen. It could get processed straight away. They could check right away. Transfer starts. It's done. So anyway, that's what I'm doing today. Is we're going to create the GajuExpress service, and I'm gonna try to write through the back end of it, hopefully as quickly as possible, because we're getting pinched on time, and some things this morning that should have taken like 10 minutes ran a bit longer than expected. So I am getting a late start, which is why I'm going to be going through coffee, because lots of things have been taking extra time lately. So without further ado, which I'm saying quite a bit at the moment, that's not it. Trying to get the right screen to share. I have like the giant screen that nobody would ever be able to read anything on if I used it for the stream. And then like I have a screen over here that's the one that you can see. Okay, that's in now. Put myself up in the corner. Prop myself up. Just enjoy the stream and uncritically accept everything I have to say as received wisdom, because that never goes wrong. And as we all know, my opinions are uniquely and objectively correct. So we'll get this over here, blow you up. All right. Now, I worked on some of this already a little bit. I got an interface built out. Okay, I don't have GajuExpress yet. We are going to take a peek into, let's see, GajuExpress. Okay. Now, this is going to be, this is in the same network, so I have to change that endpoint. Okay. Now if we look at the source and we look at the meta here, this is a ZX generated project, and it has been it's the template that you'll get from ZX. I've removed like some comments from it, but that's where we're starting, is just with this. And whoa, I had the wrong window focused. Neat. We're not typing into chat, we're typing into the thingy. So okay, GE client. If you've ever written a ZX program doing like the little telnet chat interface, what this is, it's just an echo server to start with, and you have a socket. When you tell it to listen to a certain socket or a certain port, it just opens a socket and it listens to it, and you can use it kind of like a lightweight broadcast telnet. So if I run if I do run local, assuming I didn't break anything, yeah, I didn't. So if I do GajuExpress listen, we'll put it on 7777. It's listening on that port now. If I open this and I do like telnet to localhost and I go foo, it'll say message from you, foo, right? If I have another guy, same thing, telnet, localhost. Okay, and I say bar, message from you, bar, message from this guy, foo. Hey, you, right? This guy gets the message, hey, you. And if we look over in the running window, it's this. So we're on the network. We can talk to each other. That's all. It's just a broadcast telnet. It's like a telnet broadcasting. That's all it is. It's really, really simple. So I think by was the commit. Yeah. So by is a magic string that it looks for in here. So this is the loop. So each different client has their own process that represents that client within the system. When it receives the message TCP socket bye, then that's it. It just like it matches on that, and that's the shutdown signal. So we're connected. We can connect from telnet. We can do that. So we know that that's true. Now over here we have GajuDesk, and let me make sure I'm on the right branch. Yep, I am. So unless I broke something, this should just pop up. It did. So this is Derpy McDirkface. I think that's right. Okay, so we're connected here to a local testnet. So this is Groot testnet. This is the real testnet. So if I go to let me open a new browser session. Okay. Whoa, that's huge. Okay, bring you down to earth a little bit. Okay. So if we go to the faucet, oh wait, not Groot. It's testnet. I think it's just testnet. Gajumaru.io. Okay, so if I go here, so my other mining key, these keys don't mean anything. I mean, it's testnet, so they don't really matter. So let's. Okay, so see, I've got 10 Gajus now. That's just how the faucet works. Very, very simple. So that's where we are. Oh, okay. You see the code. Let's take a look at where that is. Grep code inside of the GUI case code of block code. Okay. GD GUI 321. So we're gonna open the GUI thing. Go to 321. Okay. What is happening there is I don't have new lines because I forgot to put them in. The reason I'm listening to code, what those are is they're key codes. This is Bob. Bob has a lot of Gajus. Or is that? No, that's just a lot of pucks. None of these guys have a bunch of money. So this is a different testnet wallet. Anyway, what's happening here is if I type into the keyboard, we're getting key codes. That's what says code. We're getting codes there. There's some negative content, one allocate, whatever. Like these are just messages coming from the WX background. Oh, and I know what that message is about actually. So let's get. So what I'm doing in here is as I type. Oh, wow. Cool. Okay. So what's happening right now is if I type these like unassigned letters, they pop up. So what's happening is right here, handle event, WX key code. So that's when I type into the main interface. I'm getting a message about each one of those key presses. If it's 69, open Express. If it's 70, open Doomweaver. So what Doomweaver is the it's actually Fate Weaver. I'll change that in the module name later on. But basically, if it's not one of these two keys, then show me what the code point is. So that's how I discover what the code points are. When I'm programming, is I'll have a thing. It's like, show me the. So I'm typing, right, and you can. That's happening. Blah. Okay. Now, one key that opens a service is E. That's for GajuExpress. That's this. So we have the GajuExpress interface, which is, I would put the destination ID in here, how many days I want the transfer to be available, what file. It's like a file picker thing, so I can pick what file to put in there. Do I want to sign the transfer, yes or no? You might want to have it be an anonymous transfer, or you might want to sign it to prove that you sent it to somebody. And then which key am I signing with? Like which one of these are the three accounts I have access to inside of this wallet. Which one of those should be the sender? Now down here we have transfer size. We don't know how big the thing's going to be because we haven't picked anything. And the cost of the transfer, the service is going to have to give us a quote based on the size. So that's like, it's pretty simple. On the left side, you've got the check for downloads. The way this works is you have this key up here, whichever key you've got selected. Whichever one's selected, when you check for downloads, you're checking for downloads for that key. And to check for downloads, you have to authenticate who you are. And so you're going to get a challenge that'll pop up and it'll say, like, do you want to sign this message? And it'll be just a message signature to log into the GajuExpress service. So you say yes, sign it, send it back. You've authenticated now to GajuExpress. GajuExpress will then send you a list of the things that are pending. And then you pick a thing that you want to download. That's why the button's disabled. You pick a thing you want to download, and it's good to go. And so it downloads, then it unpacks it for you. It can decrypt it with your key because you have your key. And the service, GajuExpress, deletes it from GajuExpress service. It's gone. And that's it. So transfer expiration. If I send a file to somebody, how long is it going to live on that in the GajuExpress service before GajuExpress gets tired of it and, removes it? That's what that is. So how long are you paying for storage? So the size, the transfer size and the transfer duration are multiplied together against the price for storing a byte per whatever day. And that'll give us a price down here in pucks. Well, we'll format in Gajus. We'll start with pucks. We'll format in Gajus. So that's kind of how this works. The other thing that we pushed is if I push F here, the contract interface popped up on another screen, but it pops up. And so those are our two. We've got E, we can pull that up. And we've got F, we can pull. It always shows up over there, but anyway, we can pull this up too with hotkeys. So E is the important one to remember to use GajuExpress. So over on, let's open up Express. And so GajuExpress is kind of stylist. The language around it is being styled after the Pony Express. And so the writer, this writer is a GajuExpress network writer. This is the guy that's going to connect to the client. Well, the client connection that's on the GajuExpress service. So we've got a service endpoint that's listening, and we have a the service worker on the client side that's going to connect to the service side, right? So that's the network communication part. And this is its own process that is spawned actually by the GajuExpress service, internal service worker. And that's how we make this work. So what do we want to do to start with? We're just going to do the telnet thing to start with. We'll just do this. If so we receive, I think it's like called do check. Yeah. So if we receive a command button click and the ID is the ID for the check button, then we're going to go to do check. So what do check does is if we don't have a writer, we're going to spawn the writer. We're going to give it an endpoint to start with, and we're going to call do check again because we've got it spawned. So if it's none, we're going to populate it and then go down here to check. Now, let's see. Then, okay, we'll tell that the writer has stuff. So that's going to pop out over here. So let's try that real quick. Let's open the interface. Let's check for downloads. Okay, now we have localhost port 777. So every time I click that, we have a bad state. Cool. Writer PID. Okay. And then over on the writer side, are we blocking anywhere? Because we might be. Center host. Oh, yeah, receive stuff. So host, we were only getting that first message back. So let's do this again. We're going to open a test wallet. We're going to open this thing. We're going to check for downloads. Okay, now we can do this a bunch of times. Okay, good. So let's keep that up because it's annoying to restart all the time. Let's have this guy connect over the network. I'm going to check some of my old code here and see. I have a set of like network options that's really robust, and I always forget to like what it was. Peer, it might be the peer one. What I should probably do is check. Oh, OTPRZX. Grep, what is it? Gen, TCP. I think it's connect. I'll check it in a second if it's wrong. Okay. Auth con. Okay, so con. Okay. Packet 4 mode binary. So we'll go with binary mode. Packet 4. We don't really need that other than so we want to have the so what packet 4 in the socket option does is it gives you a prefix that's 4 bytes that tells you the length of the message that's coming in. That's really useful. It's really useful after you're in a mode that's easy to kind of debug. And when I say kind of easy to debug, what we want to start with right now is maybe like a little more simple with so we want an accept option. We want to open the socket with accept, which we're already doing. Let me check how we're doing it. We're going to have our GajuExpress client manager. Let's see how we listen. How do we implement listen? Right, here we go. So inet6 packet line, blah, blah, blah. Sure. Yeah, keep alive. Reuse address. That's important because it's really annoying if you don't. Okay. We're in line mode, which to get this started doesn't matter. Let's connect that way. So how did we start this off? We got an address and a port, and we should be able to just like TCP connect to that. Peer maybe. So we already got the acceptor. Want the connector. Okay, so we're going to go with we're in binary mode. All right. So we're going to open the same way here. Let's see if we can get that done. Case gen TCP connect. It's like host port options. We're going to need to make some options. Mode binary active once. That's probably good enough for now. Host port option options. It should automatically do the inet6 thing or whatever if we're opened that way also, which we are. So actually it should be fine. These all should just like go. And then we need to have a timeout. We'll do 5,000 seconds is like forever, but that's fine. Do we have a socket? We do have a socket thing. Okay, so we're going to enter the loop then this way. Socket equals socket. And what if this fails? We want to fail. Do we have the logger? We do have the logger. So we're going to fail really noisy and die. Failed to connect to the host. and then we're going to just exit normal. Now, if we don't exit normal, we'll blow up the Express process because it's linked to it. So I'm pretty sure that's right. So if we do connect, let's send something over the socket first. Gen TCP, I think it's just send. And then socket, and then we should send a message. It's about sending a message. GajuExpress 001. Okay. So what should happen is we should connect, and then this GajuExpress 001 should show up over here as something that a client said. And then if we get a retire message, maybe we could do, what was it, bye? Oh, we're going to do the RN thing here too. We're going to have to line terminal because the other one's in line mode. Okay. Oh, how do we turn that to line mode? Packet line? We'll do that too. Okay, that way we'll get these got messages back. Now I'm going to cheat and what was it called? Express. And then recompile writer. Oop. Okay. Okay. Now we're still running. I just reloaded that. We're going to open this again. We're going to check for downloads, and we crashed. Okay, cool. Let's see how we crashed. Oh, okay. So this is linked into address, localhost port, blah. Okay, let's add a tell here. Started, yeah. Not getting the log message back, though. Bad arg, offender GDCon. Bad arg. Am I putting in the wrong thing here? Okay, let's try from the shell connecting. I'm doing something silly, obviously. Gen TCP connect port, and then what do we have for options? Okay, I got a port from that. Okay, we just got that. Local inet get host. Did I not start inets before? Reach max and restart intensity. Okay. Oh, there's going to be the options problem too. Not that it matters right away, but I need to set the active once thing. How does that work? Oop. And set up socket. Otherwise, we can't get the message. Okay. Okay, it's nothing about that. was my ensure started thing? I don't think that even matters for this case, but nope. So my Gen TCP Connect call is like bad somehow. Localhost port 777. That's correct. Oh. I'm having a weirdly hard time getting started on this. Okay. Is there anything textually different that my eyes aren't seeing? No. Mm-hmm. I'm just playing with this to. This is what happens when you have sort of mysterious shit that, okay, so something else is going on. What have I done down here that's crazy? Okay. What did I do in here? Okay, that's there. We already ran that. Not doing any of this. Oh, well, we can't actually set the socket, can we? Because we don't have one. Doom, doom, doom. Okay, that works. Obviously not if I do the other thing there. So, well, let's try this. Bam, right away. Okay. Oh, packet line. Okay. Okay, because I'm receiving both. Because I got two different ports. One of them is 19, one of them 16. They're both open to me. Okay. So it's not opening a port that's fundamentally not working from the runtime. That is working. Something else is blowing up. Oh no. Yeah, and the socket's closed. Cool. Everything's still clean like it's supposed to be. What's funky is that I'm dying on Socket Connect inside of here. What do I have backwards? I have mode binary. I have active once at packet line. That all seems cool. Let's try that again with these exact options. Maybe that's just, I don't know, typos. Gen TCP. Oh, you know what? I'm going to match on this and take it like I did a second ago. Connect localhost. Here's those options, and then 5,000, which is exactly what I just did there. Oh, I have it. Let's send a message. Let's flush. Got a message back. Let's send by. Okay. And yeah, he closed out. Cool. So it's all gone now. So those options were fine. Init is occurring. Maybe I should separate this just a hair. I gotta isolate this case. This will give me more options later. Put this in there. We would just want state to that. No. Yeah, just this way. I'm being silly. Okay. Not this. Did we get options? We didn't get options. Okay. That exit clause. Okay. And you're just checking your blog. Do you speak Japanese? Yes. Yes, I do live in Japan and I speak Japanese. These, so hello, Krishna Putra. I'm sure I'm saying that wrong. Yes, I do live in Japan and I do speak Japanese, and these sort of online working is the only time that I really get to speak English because nobody speaks English around where I live. All right. Let's see. Port. Oh, yeah. I didn't separate that, did I? Oh, you know what? I know exactly what I did wrong. And I see it now. I've got the host separated and I was putting in ha ha ha. Okay, so that was me being corny this entire time. Also unbound there. Well, wait. Let me separate this. Okay. I'm pretty sure I know exactly what happened the entire time through that. Yep, it did. And I sent that and I got the message from you, GajuExpress. Yep, okay. And this guy got the connection too. Okay, so that was entirely driven by me being silly. So I can push these back where they kind of belonged earlier, which is into here. Yeah. Whoops. That was silly of me. So we're going to delete that, add back to host equals host. Okay. Now I'll rerun this and everything goes like it's supposed to. That was just me being corny. Anybody watching that and catching on to what I was screwing up would have been like yelling at their screen going, hey, why didn't you get that right? Okay. So yeah. All right. What we're going to do is we're going to send a counter. We're going to add a counter to the writer state. Oh, actually, you know what? We're going to check these exit normals, make sure they're not actually blowing us up. Oops. Oh, you know what? That's interesting. So I can kill the thing with an E enter if we don't have a wallet open. Why? Because we don't have any accounts. So I have to catch the case where that's interesting. So I have to catch the case that we have pressed E, but we also have to have a wallet if wallet's none. So handle event. This is an express. I need to be in GD con. No, not con, GUI. In GD GUI. So where do we have accounts 0? So if count, okay, so if the accounts list is empty, then we should not. We should avoid going to Express. We should also avoid opening Doomweaver, actually. So Express and Doomweaver should just return state if the accounts are empty. So we're going to open a new clause here to protect ourselves from that. What was it? Accounts. So if accounts are empty, we're just going to return state and do nothing. Same thing with Doomweaver. Same deal. We're just going to not open that because that means we don't have. Yeah, that means we don't have. We're just not going to send the message. Oh. Point. Okay. Yeah. So see, now we're not sabotaging ourselves with these impossible things. Fate Weaver. I called it Doomweaver. Well, I'll change it. In the code, it says Doomweaver right now. I will set that real quick. It's a quick search and replace. So previously we were looking for good names for the IDE, and we came up with looking at like a Tolkien-esque. We had a lot of different ideas, but Tolkien-esque sort of world. Because smart contracts are always deterministic, they are fate or they're doom or whatever. And the so your doom is or whatever your ending is, whatever's inevitable, and fate is the virtual machine that Gajumaru runs. Fate, doom, whatever. So we're like Doomweaver, and it's a funny name because open the Doomweaver, which is a fun idea. But anyway, Fate Weaver sounds a little bit less ominous in modern English. But I had already changed the module name to Doomweaver, so whatever. Cecil, I'm upsetting you unnecessarily about names. Anyway, Alice, Bob, Jane. Why didn't I start with like Chuck or something? The ABC. You know what? I can do that. I can rename this. Jane is no longer Jane. Chuck. Oops. I'm stealing character presses. That's why. So I need to bypass. Yeah, so I'm stealing character presses from the interface so that I can do this. That's interesting. So that's a fun detail of the key press event. So I need to do a key press event that doesn't steal focus from a modal, which this is a modal. So it's actually the same. It's the same like process window. And I'm stealing the character press. See, because that's what's happening. And this opened because that's the key press that was received when I press E. So it's going to be one of those callback-y, callback like key press handler things. And since all the code looks correct, right? A test suite won't catch that. That's the fun part about GUI programming, is that you can't really see those until you actually encounter them. So we'll have to do some thorough checking on that later. Anyway, what I want to do right now is, okay, yeah, so we're going to send the counter thing through, and let's see, GD, what was it? V Express, right? So when we get the check button, so the writer is going to have what? This is a simpler case to put a counter into. Okay, count. And do check. We're going to send stuff, not the best verbs here. Okay, host. We're going to send to the socket a message This should actually work just like that. Oh, we need the RN. And then we should get the message thing back too. Oh, we're going to loop state increment to the counter. So every time we click check, it should send a message off there that says count 1, 2, 3, 4, and we should get the echo back from that, and we should be able to see it on the server. And what we're doing is we're just proving to ourselves that we don't have any weird like edge casey thing that's kind of funky that will blow us up later by surprise. See, that's working. And if we look over here, we're going to be getting the same thing. 6, yeah, okay. So we are talking over the network. And things are going fine, except for our key intercept here that we have to fix. But we'll do that later. Okay, so what are the things we want to actually tell when we do a check, for example? When we check, like do check is going to actually be, we're going to want to check what? The public key that's selected. So we need to get the public key that's selected. Can we? No, we can't. Do I have a junk file? I do. Look at that. All right. Where's our picker? We're just going to print stuff out first to like make sure that we're not crazy. So we have the keys. We have the keys. Well, keys is a WX object thingy. Keys equals. So it's a listy picker thingy. We're going to have an index, which is what? WX, I don't remember. WX object, blah, blah, blah. What interface, man? WX. I don't remember what it is. It's a list control, I think. I form it up here. I should just check what it is. WX choice. Okay. So I think it's just get. It's like get selection. Control with items. I think it's control with items. Get select. Yeah, it is. Okay. So get selection. Do check. So WX key p index equals what? WX choice. Get selection. Key p. I think that's the index of it, right? Get string selection. Returns the label of the selected item. Okay. So we would actually want case WX choice get string selection key p of, if it's empty, then we're going to what? Go back to state because we have nothing to check. If it's a key ID, then we're going to do this other stuff. Don't want that. We're going to check. So check the PID and key ID. Check the key ID, please. In both cases, we don't need to change the state, so we're just not going to mess with it. So we're just going to return state at the bottom so we don't have to touch it. Don't forget anything. Writer check. Okay. So the check call in the writer, which we don't use for anything right now. So we're going to change it to check ID. Check ID. It's going to need to be a call thing. So what we're actually looking for is going to be receive. Nope. Actually, what we're going to want to do is fire that off, not touch it, and then we're going to want to put a we're going to receive a message from this guy whenever he gets the response from the service, like you have. So we'll make this guy wait on it, and we'll have this one update the other asynchronously, so we're not waiting. Okay. So he's just going to get an okay. Actually, this collapses, doesn't it? That's it. So writer check. To front, trouble, pending, accounts, pending. Okay, so pending is going to come from this guy. So if we get a message, check ID, what we will do check I'm going to switch this protocol around to being both properly binary in construction and then also prefixed, link prefixed on both sides, because we're still doing this like RN stuff, which we don't actually want. So we click the check button. We send a message, check ID. We'll separate that. We should get that out, and we should get the return value back too, and it should be just fine. Get rid of this counter shit that we don't need. Sender, host. We don't need that anywhere in here at this point. We need do we ever just have a message to send to the writer? Maybe we will later. It won't be stuff. It'll be something else. Okay, retire. We're not even doing retire with this guy, but it doesn't matter. Oh, yeah. Is this all build? What am I missing? New host is unbound 65. Oh, yeah. Because we're not doing that at all. Right. Host is unused in loop. Yes, it is. It's more of a state inspection thing later, like who are we connected to, which could be handled just by socket, but we'll play with that later. Okay. Yeah, so that worked as expected. GajuExpress blah. Check for this key. Let's switch the key to this key. Okay. Okay, so we're doing good. We're sending the check message to the service like we want to. What we want to do now is we want to try to start this. And okay. Okay, cool. We don't have a way to retire the guy yet, but that is good. So what we kind of want to do is have a down. We'll want to have a down message that we can use from this guy. But what we do know is that the failed to connect thing is working like it's supposed to. We're not sending any message, any notification back to this guy that like I'm dead. I do need a parent. Or wait, I already know the parent. GajuExpress is a registered process, so Okay, so what we're going to do here is like, we're going to have a thing called, have a function called retire, and it's going to and this guy's handle info. Just have okay, just retiring with reason, and then we're going to no reply. And then we have no writer. And we should be able to do this over and over. If I don't, oh, that was dumb. 72. What else did I have? Retire 1. Well, let's switch it to stop. Some more normal function for that anyway. What did I do here? 53. Why did I do that? There we go. Silly me. Yep, retired with normal. Okay, cool. So totally fine. Probably want failed to connect to. That's not. Oh yeah, that is right. Yeah. So before we call, okay, yeah, that's fine. What tell versus log does is tell lets me see in the console that, look, econ refused. That's what that it just lets me see that. And the writer retired with normal. Okay. So this is all going the way that we want. So we want to switch these options around to being first, we're going to start out with a blank thing. We're going to accumulate up to a. So you have to wait for acknowledgement. We can just start it in packet 4. I'm fine with that. It should be pretty clear, even like Wireshark. There's going to be 4 bytes. It's going to be a length. It's going to be like 000, whatever this is, like 12 or something. And then GajuExpress 001. My printer is possessed. I'm going to change these connect options over here. Packet 4, where binary wants keep alive, reuse. Yes. Oh, actually, we want to do keep alive true also. So binary active once, packet 4, keep alive true, sure. And that's what we're doing over here. Now what we're not going to get anymore is we will not be getting these. Yeah, we won't get those end of line things anymore. We won't need to send the end of line things anymore because we have this stuff should be Gaju. Okay. Okay. Yeah. And I don't need to put the new lines to this now. Okay, so we've transitioned away from line termination into prefix sizing, which is good. Now, this guy's going to need to issue a challenge. We're going to want to start sending terms back and forth. So we're going to want to get things like a socket message. We don't have a relay anymore. So actually, what do we have in here? Start, listen. Parent, listen, socket, sure. So how are we? This sends yourself. Okay, we don't have that relay message anymore. Did we have a relay function? No, we just had a message. Okay, so relay. GE client man echo. We don't have an echo. Don't have an enrollment thing. Yeah. Pretty clear what that does. No echo messages are coming. Could have an enroll message. We've got nothing to broadcast though laterally. The service is actually super simple. We just don't have this. Do listen. Yeah, do ignore, sure. Do enroll, do echo. Handle down. Okay. This guy's real job is to own the listen socket. I don't think we even need to enroll clients. I'll probably get rid of that because we don't have any reason to enroll clients. I don't think. And ongoing sessions are, we can find out what we need to by checking the client supervisor if there's any children, because they're all going to retire and go away if there's no socket open. So, and that would be the shutdown criteria. Okay. So what happens when we receive this? We're not going to format that. We're going to, well, we might to start with, but we're going to do handle going to make a function called handle message. I don't think that I even need to have these because there's nothing here for them to do. Probably get rid of those. I'm talking about the system get state and system replace state. I think those are just handled by, oh no, those are handled by Gen. Yeah, those are handled by like the Gen module. I don't think those are handled by the lower one. So maybe I do have those to be like OTP proclib compliant. Anyway, these implementations are really boringly simple. What I want is handle message. And the first thing we're going to do with handle message. Okay. Oh, wait. What are the canoe? The canoe. What are the two connection types we might do? So we don't actually want handle in here. What we want is differentiate which case we're in. So we get this. Okay. Okay, we're going to enroll later, if at all. We're not even going to have a loop. Oh, no. Okay, so we're going to receive TCP socket. GajuExpress 1. What'd you call it? Sender? Sender. And then TCP socket. Okay. So if you're a sender, you have a little bit of negotiation to do. Just dispatch straight away to what would we call it? Writer, customer. So he wants to deliver a package. That's what a writer does. Who gets the package? Recipient, customer. That's a kind of thesaurus type thing to check up on. I'll have to think about that for a second. Uh-oh. I will be right back. I have to go check on something at the door. I'll be right back. Okay, getting back in here. Let's see if my camera turns on again. Yay, I'm back. Okay. So, continuing on. What do I have happening? Okay, so dispatch. What is happening here? Actually, I'm going to get rid of the state because we don't need a state. It's only got one thing in it anyway. We're just going to have the socket. We're going to dispatch on the socket. Get rid of all this. Okay. So we're going to receive from the socket whether or not he's supposed to be a writer or a recipient. And that, what's a synonym for a recipient? Is there like a thesaurus? Donee. I've never even heard of a donee before. Giver, taker, that'd be kind of funny. I've never heard of a donee before. Is that a joke? Recipient, receiver, donee. Oh, that's just nuts. Don't care. Okay, so okay. So receiver is going to have to go through an identity check. There's not even going to be a loop in this module. All this module does is it's going to receive the connect. It's going to make the connection. So all the networky junk at the top, that's like initialize a process, and then like if you receive a thing, then spawn the next guy, which is what this is. It's just a tight loop over receive, spawn the next worker, receive, spawn next listener, that thing. It should go to dispatch after that. And what dispatch is going to do is it's going to check. We're going to have like a prefix message. The thing is, I want them to be the same size so it's easy to catch. If you're looking at the binaries on the wire, I want these actually be the same size. So writer, receiver, we can like make the four. Whoa. We can do the ugly 4-letter like receiver, which is horrible, but it is the same size and it's easy to catch. The last couple of bytes will be different. The last 4 byte or the last might be too similar. That's why sometimes I do it with numbers. I just have like 1 and 0 or whatever, or type 1, type 2. But I would like this to actually be visible. Hopefully in ASCII for people who might be listening to try to figure out how the protocol works. I would like them to know how the protocol works because this should all be super transparent. Anyway, writer, receiver, whatever, it's fine. So when you're checking your receiver, when you're sending your writer, and so over here, we're going to be sending on check. If we do check, so when we send check, we're going to send to the socket. The first thing that will go out will be GajuExpress 1 receiver. And we're not even going to do that here. Okay, because we're just initializing. And initializing, I guess I could write 2 different ones. I could have a writer connection type, and I could have a... It might be better to call this guy the receiver rather than the writer as a module because I'm doing the receive side. Whatever, we'll do both to start with, and then we may differentiate this as well that the check guy is going to be the receiver and the send guy is a different module that just specializes in sending. That's probably better. I will probably do that. And actually, with that in mind, if that's the purpose of this guy's existence, what we actually want is when you click the do check thing, yeah, I like that better. I'm going to save this as the GD in receiver. And we're going to jump over there. Okay. Okay, we're not going to have a stuff check. We're going to have an init thing. I think I got bit by an ant or something. Ouch. That's uncomfortable. I'm going to scratch my back here with a ruler because I think I just got like, I don't know, bit by an ant or something. It fucking hurts. Okay. So, check. Why are we ever opening this connection? We're opening this connection specifically to do a check. So we're not going to have a check verb. We're going to have an init too. We'll decide. So the structure of this module is going to change a little bit here. We're going to have our start stop. Start stop is just here. And the second part of this, the second argument is going to be our ID. And each different key that we might be checking for will just spawn a new process with its own socket and its own thing. And we're just going to make this, like the receiver, be narrowly focused on receiving and the writer be narrowly focused on writing. And on the other hand, we're going to have the same thing. So on the socket receiving side over here, this code is doing the listening, it receives, we're going to go dispatch, and we will, when I say dispatch, what's going to happen is this loop, these loops will be different places. One of them is going to dispatch to like a GE writer module. Another one will be a GD receiver module. And they're so special. The tasks are so specialized that it doesn't make sense to have them in the same module. It'd be confusing to read. I can just break these apart, and that's better. So we got the host, we have the socket, and we need to have an ID. ID. I think it's a string. It's a string the way we had it earlier, right? Whatever. Maybe there'll be binaries. We'll just have it be a binary. It's fine. It's fine. Empty binary to start with. Okay, ID. Makes more sense to say I'm checking this ID at this host rather than I'm checking this host with this ID. So I'm going to put it first in the argument list. Yay. Okay, so that thing here where we're not going to have a loop because, well, we might. Yeah, we might because we've already authenticated. So that's good. So the next thing that we will do is we could request, we might iteratively request multiple files. So we will have a loop, but we're first going to do a verification check. So, we should identify ourselves as a receiver right out the gate. So we're going to connect. We got the socket. It worked. Say, hey, I'm a GajuExpress 1 receiver. And we won't get a message back yet. We're going to go into, not the loop, we're going to go into the authenticate step here. So authenticate is going to be down here. Probably want the ID also. Again, that's cognitively a little bit reversed, so I'll put that first. Just so used to networking stuff that pretty much only have the socket going, but we will want to do this. We want to receive once. If we get TCP socket message, we're going to want to unpack the message. So after this first part here, and we're already doing prefix terms, we're just going to do we're going to unpack these binaries into Erlang terms directly, and we're not going to fool around with a bunch of protocol-y stuff. The protocol will just be Erlang messages. We know what both sides are expecting, so there's a specific pattern that these messages should follow. If they don't match the pattern that we're expecting to unpack to, we're just going to say you know what, that's not the service we thought it was. Bye. That'll be it. So what we're going to check is we're going to make sure that the string that we get in, the signature string that we get in, has GajuExpress in it, so that it can't be some somebody can't just pass you some trash to sign. That could be a encoded chain instruction or something like that. Now our signature procedure already does that, but here we want to match it to and make sure that we're talking to the service we expect. So we're going to do case binary to term, which there's a switch for that. That's the safe one. You don't want people to be blowing you up with fake atom generation, which is in this case not that big of a deal, but on the server side it's definitely a big deal. Where are we here? Oh, whoop, no, it's a built-in. Built-ins are in the kernel? The kernel? RTS? I don't know. No, I never get that right. Binary to term 2 has an option, and the options don't want that. Safe, that's the one that I want. Okay, so binary to term, well, that's what I want, and I'm going to change this to binary. Now, yeah, okay. No, there's in the ZX library, there is a different Gerlab. That's not a thing that exists. I can't type suddenly. I've lost my skills. Personal project, and then there's in the ZX library. I believe there was actually a beta T, beta TS, and the reason I would use that is so that see beta TS. That's the one that I want. It catches this and returns them as tuples, so I don't have to do the try catch crap. I hate polluting code with that. So what we're going to do is not this. We're going to do cx lib b to ts of okay. Binary of okay. Now what's the verb that we want to send? We could wrap it in instruction, or we could wrap it in, it could just be a binary. It's going to be like some random junk though, regardless. GajuExpress auth would be a challenge. Okay. We'll do it this way. We're going to get the challenge message, and in that case, we're going to it's just going to be a pass-through. What I'm pausing thinking about is function names right now. I want this to be very plain for people to read. I don't like a lot of nesting, so I'm thinking so we didn't even do that yet. We'll do handle challenge. Basically, I'm writing one long function. It's one single procedure, but it's got a lot of kind of like escape points in it. Pretty sure we're going to use this here. Okay. Tell. What was the error condition? Error. So if it decoded correctly, but it's the wrong term, then we will log that and retire. Okay, so error. Was it bad arg? So this message needs to be a binary or a list. It doesn't matter which one it is. Regardless, it'll be a string, and it needs to be. This is where we want to put this match in here. Okay, what this does is it's going to match on the front of that message, and if it's not prefixed with Gajumaru challenged meh, then it'll barf right there. So okay, so accept the challenge message. We have a what was it? Sign binary sign message. So a sign binary request, and the request is this like map thing. Okay, and so this is like a grid specific deal that's going through here. We probably want to like get some of this away from being those grid specific messages, because it's going to come back as like a grid specific message. We want the procedure do sign binary 2. Yeah, see, it's going through like decode payload and all that, but we don't have to do any of that dance because we're not doing the JSON. It's a much more direct HC sign binary secure key. Okay, so we'll have a sign binary 2. How does sign message work? It's pretty much the same, I believe. Yeah, it's the same kind of deal. So maybe base 64 encode and then list binary message. Right, okay. An HC sign message is the way that we do this. And the verify will be the same sign message, or verify from Hakuzaru. So we'll use signed binary. We use the HZ signed binary, but we're going to make a signed binary 2. Yeah, okay. Okay. Oh, it's I don't need the ID anymore, do I? Oh, I need the key. That's I'm stupid. Wait, I've got it. I've got the key. So message set key, and the message is a binary already, which means that I'm just doing HC sign binary message set key. And okay, so there's two things that this might be, and it's going to actually I don't even need sign binary 2. I can just do okay HC sign binary message. Is that right? Don't even need that. Okay. So do sign binary 2. So how do we want to pack this back to the thing? We are going to have the auth ID signature message. Well, he sent the message. He already knows it. The ID and the signature. Cred. Okay, let's see. Term to binary. Send over the socket this credential. Okay. Okay. iNet set options for the socket. Active once. Receive what? Receive TCP socket. I would assume we're not going to have a ridiculously huge list of things, but we might want to wait a few. We'll do a few seconds for right now. Okay. Okay, here we go. Now we're cooking. I want GDCon. Oh, no, not GDCon. What's this called? Express, yeah. Pending. Let's keep that. I like read. because that's what we're doing. So read manifest, GDCon, not GDCon, GajuExpress, pending. Manifest. We'll decide how the form of that later. It's kind of the end of the line for us here on the receiver. So it raises the question, do we... Yeah. Okay, so what we're going to do here is we're going to get this as okay. Okay, we're going to loop on state now. Oh, look at that. It's all the same. So, yes, we're there now. And we will have a fetch. Fetch parcel. Okay. Okay, we're going to have a fetch. Oh, it'll have to be 2. So fetch the parcel. Parcel's going to be what? An ID? What kind of an ID? It'll probably be a hash, right? So we can just leave it as a binary, which tells us what the parcel ID. It's more clear. And this is going to receive what, the mochila. Put the parts of it on disk to a temporary spot. That'll be it. So we're going to have a fetch. What is the one? TCP closed socket, something? We're going to want that. It's in here too, somewhere. That's right, it's TCP closed. Disconnect. Yeah. So I'm adding the state to that so I don't ever have to remember about closing the socket or anything. Not that I really have to, because it's exiting. But I prefer to signal the other side instead of just dropping. Oh wait, what am I doing? I already did that. Okay. Messages coming from somewhere. Oh no! Okay. Well, I'm going to have to cut this short because I have to go pick somebody up. That's what that turns out to be. Anyway, so what we have so far is we've got the read manifest. Okay, so when we're a receiver, we start this function. It goes straight into an authentication routine, which means the other side over here is going to do the same thing. It's going to immediately jump into authenticate. There's no reason you would be connecting as a receiver if you're not going to authenticate right away, because you can't. There's nothing you can do. So there's no choices to be made here. You're going to say, when we connect with GajuExpress 1 is like a version number for the protocol. So if I have a GajuExpress 2, I could like handle both of them if I have old clients or whatever. It's way down the road, but you kind of want to version your protocol so that you could do stuff like that. Anyway, if you send the message GajuExpress 1 receiver, then you're going to authenticate right away. That's like an intention to authenticate. So you're waiting for them to send a challenge back. So you get it. Oh, I need the TCP close thing here too, which I didn't do. In that case, we want to go to retire. Ooh, don't need it on that. So they're going to send a thing back. It should decode from term to binary should decode, or I'm sorry, binary to term should decode it to this challenge and then message. Then you're going to accept and the challenge should be formed this specific way at the beginning. Challenge accepted. Then we signed the thing. We build a credential in term to binary. We send that back. Then they should send us a manifest. And the manifest might be empty. But that's in this logic, that's all we care about, is that we connect, we authenticate, they send us the list of stuff. So why don't we proactively authenticate? There's no way to proactively authenticate that works well. You need to get random stuff from them and then be like, sign this trash and let's see if you can. And if you can, they'll know because you sent them your ID and they can check that this ID matches that. Then they check that ID becomes a key that they check their backend and see, do I have any messages for you? And if they do, they send you the ID of those messages so that you can then request them in the context of your communication with them. And I say in the context, we're keeping a TCP socket alive this whole time. So you actually have a running context. Let's see, get list, read manifest. Okay, yeah, so the pending manifest, we're going to send the GUI for GajuExpress, the manifest, so we can show it in that left panel. And then we're going to go to a loop because we're waiting to see if the user in GajuDesk wants to pick a file or not. Now, if he changes key, we're going to retire this guy, right? Because we're going to just authenticate a different one, that type thing. So every time you switch keys, we'll want to, and you hit check, it's going to do the signature thing with the GajuExpress endpoint. When you actually receive an encrypted file, this will decode it. It's roughly as complicated as what's happening right here. Is we're going to create a directory that's a temporary directory that's named after your key. We're going to make a file in the directory that's named whatever the file ID or the package ID, the parcel ID is. Stream the contents to that, then try to decrypt it. If that doesn't work, then it's not really yours. Stuff like that. That's it. Anyway, I have to go pick somebody up. I will be continuing this afternoon. I'll probably finish this today because there's not that much more to do. There's like reading files, hashing them to get a name, signing them or encrypting them, sending that. It's just it's stuff. It's more of this. It's not really hard. Um, the key is that the payment on chain, that's going to be interesting. So that's going to be probably the coolest part of this. Is that to pay for the service, you have to make a on-chain spend. The on-chain spend will work, pretty quickly. We have a blocking call for that now, which is great. So I can tell the service, hey, I paid, like, for really, really, here's the receipt. And they can look at it and be like, oh, yeah, you did. Okay, proceed. We can do that very smoothly. So lots of good things should come out of this. But again, my goal here is that we need to fix this problem where, like, normal people can't send truly encrypted, actually secret data between each other, because everybody's horrible these days. So anyway, that's all I got. I will catch you guys in the next one. Hopefully I'll be able to stream tomorrow. Not really sure. I'll be looking into some authentication things next day or two, but this should be wrapped up today or tomorrow. Authentication thing, that'll probably take a day or so. There's some investigation I got to do a bunch of reading to figure out which auth backend we want to implement. But these are two fairly important features that should be able to push out this week. So yeah, today or tomorrow finish this, then authentication, and then if I get a chance, I would love to do a plugin for GitT that uses like our Gajumaru style, like the grids authentication. That'd be awesome. If we could use GajuAuth to get into our own GitT within a couple days, that'd be fantastic. If not, I might have to defer that and do it a little bit later because we have to get Gaju Mobile. And the really cool thing is all this ties together with Gaju Mobile even better. So that's kind of where this is going, but it's just a time crunch. Takes time to get these things done properly. So anyway, that's all I got. Catch you guys in the next one. Well, I clicked in stream, but I'm still on stream. I'm trying to get out of the stream. It won't let me. Whatever.